You need to hear this if you've ever looked up at the stars and wondered what's out there. Imagine, right now, as you stare into the night sky, you could be gazing at worlds teeming with life, or at the very least planets that mirror our own. Each star is a sun, burning billions of miles away, each one a distant beacon in the vastness of space. Some are older than our own sun, some are just being born, and each could have its own family of planets. For centuries we've wondered, are we alone? Is there anyone else out there looking back at us from another world, asking the same question? Is Earth the only cradle of life or just one of many? Our planet is teeming with life, but is it unique in the universe or simply one example among countless others? This question drives our curiosity, fueling our imagination and our quest to explore. It's a mystery that unites scientists, dreamers, and explorers across generations. We send rovers to Mars and probes past Pluto, searching for our place among the stars. Every mission is a step toward understanding our cosmic neighborhood. The idea of other worlds has captivated us for generations, not just in fiction, but in science. Stories of alien life fill our books and movies, while real scientists scan the skies for signals and signs. Discovering life elsewhere would transform our understanding of biology, chemistry, and our own significance. It would force us to rethink what it means to be alive and what it means to be human. It would mean the universe is vibrant, filled with possibility. Every star could be a sun to someone, every planet a potential home. The search for other worlds is a search for a reflection of ourselves, a quest to find connection in the cosmos, and perhaps a new perspective on our own existence. Today, we're in a golden age of discovery. New telescopes and technologies are opening windows to the universe that were once unimaginable. We've moved from wondering to finding. Every year we uncover new worlds, each one a potential answer to the age-old question. Thousands of exoplanets, planets orbiting other stars, have been confirmed in recent decades. Some are gas giants, others are scorched rocks, and a few are tantalizingly similar to our own world. But the ultimate prize is an Earth-like world, a planet with the right conditions for life as we know it, orbiting in the habitable zone of its star. That's why news from the James Webb Space Telescope electrifies us. Whispers of multiple Earth-like planets ignite our imagination and hope. The journey to find these worlds is a testament to human ingenuity, perseverance, and our relentless desire to know more. With powerful new tools, we're closer than ever to answering the question, are we truly alone? The answer may be just beyond the next star waiting to be discovered. To answer the biggest questions, we need the best tools. Enter the James Webb Space Telescope, or JWST. Launched in 2021, it sits 1,000,000 miles from Earth, observing the universe with unmatched clarity. Its massive gold-coated mirror collects more light than any telescope before it. JWST's real power is its infrared vision, seeing heat, not just light. This lets it peer through cosmic dust, revealing newborn stars and planets. By analyzing starlight passing through exoplanet atmospheres, JWST detects water, methane, and other molecules, signs of habitability. Its instruments operate at temperatures near absolute zero, protected by a giant sun shield. This combination of size, sensitivity, and technology makes JWST the most powerful planet hunter ever built. It's our time machine and our window to other worlds. Before we can study a world, we have to find it. And that's incredibly hard. The vastness of space and the brightness of stars make this a daunting task. Spotting an exoplanet is like finding a firefly next to a searchlight from miles away. The light from the star overwhelms the faint glow of the planet. Planets are tiny and dim compared to their stars, lost in the glare. This makes direct observation nearly impossible with current technology, so astronomers use clever, indirect methods. These methods allow us to infer the presence of planets without seeing them directly. The transit method watches for tiny dips in a star's brightness as a planet crosses in front. This method has been incredibly successful. The Kepler and TESS telescopes have used this to discover thousands of exoplanets. These missions have revolutionized our understanding of the universe. Another method, radial velocity, detects a star's subtle wobble caused by orbiting planets. This technique measures the gravitational pull of planets on their stars. These techniques reveal a planet's presence, size, and orbit, but not its appearance. They provide crucial data but leave much to the imagination. They give us shadows and hints, not pictures. We can infer a lot, but we can't see the planet's true nature. To truly understand a planet, to see its color, clouds, and atmosphere, we need to take its picture directly. This requires advanced technology, and innovative techniques. That's the next great frontier in exoplanet science. Direct imaging will open up new possibilities for exploration and discovery. Direct imaging is the ultimate goal. It represents the pinnacle of our quest to understand distant worlds. And now, we're finally getting there. With each new discovery, we move closer to seeing these distant worlds in all their glory. Directly imaging an exoplanet is the holy grail of planet hunting. It's the difference between reading a city's name on a map and seeing a photo of its streets. JWST's advanced technology makes this possible. The key is a coronagraph, a device that blocks a star's light, revealing the faint glow of orbiting planets. Even with this, the process is painstaking, requiring stability and sophisticated image processing. This technique works best for large, distant planets. In June 2025, JWST achieved a milestone. It directly photographed a candidate exoplanet. This isn't just another discovery, it's proof that JWST can reveal worlds hidden in starlight. A new era of exploration has begun. Meet TWA-7b, the first exoplanet candidate ever directly imaged by the James Webb Space Telescope, or JWST. This remarkable discovery marks a new era in our ability to observe distant worlds, allowing us to witness planetary systems as they take shape far beyond our own solar neighborhood. TWA-7b orbits a young, energetic star known as TWA-7, located about 100 light-years away in the constellation Antlia. This region of the sky is home to many young stars, but TWA-7 stands out for its dynamic environment and the fascinating planet it hosts. The planet itself is a gas giant, similar in mass to Saturn, roughly 100 times the mass of Earth. Unlike the massive super-Jupiters that have dominated previous direct imaging discoveries, TWA-7b is more modest in size, making it a unique find among exoplanets. Previous directly imaged exoplanets have typically been much larger, often several times the mass of Jupiter. TWA-7b, by contrast, is relatively lightweight, offering astronomers a rare glimpse at a Saturn-mass planet in its infancy. What's even more intriguing is its orbit. TWA-7b circles its star at a staggering distance, about 50 times farther than Earth is from the Sun. This wide separation gives us a unique perspective on how planets can form and evolve in the outer reaches of their systems. Despite being so far from its star, TWA-7b is still surprisingly warm. Its temperature hovers around 120 degrees Fahrenheit. This lingering heat is a remnant of its recent formation, causing the planet to glow in infrared light, which JWST can detect with incredible sensitivity. The entire star system is incredibly young, just 6.4 million years old. It's still surrounded by a massive, swirling debris disk, a leftover from the star and planet formation process. We're fortunate to see this disk almost perfectly face-on, giving us an unobstructed view of a planetary system in the midst of its creation. It's like looking at a cosmic laboratory where new worlds are being born. TWA-7b sits inside a distinct gap in the disk, a path it has carved out with its own gravity as it orbits, clearing material and shaping its surroundings. For the first time, astronomers aren't just inferring a planet's presence from the effects on its disk, they're actually seeing a planet actively sculpting its environment in real time. This is a direct, unprecedented look at planet formation in action, a rare opportunity to witness the forces that shape new worlds. Thanks to JWST, we now have a cosmic snapshot of a young world sculpting its solar system, offering new insights into the origins of planets like our own. The discovery of TWA-7b is more than a picture, it's a live-action movie of planet formation. For years, models predicted that giant planets carve gaps in their birth disks. Now we see it happening. TWA-7b sits perfectly within a gap it created. This observation connects cause and effect, showing how planetary systems are shaped. The empty spaces in our own solar system were likely carved by giants like Jupiter. JWST also spotted a clump of dust trailing TWA-7b, a Trojan disk trapped in a stable orbit. Our Jupiter has similar Trojan asteroids. Now we see this process is common. JWST's image is a baby picture of a solar system, letting us test our theories. Understanding these young giants is key to learning how Earth-like planets can form. It's a crucial step in unraveling the origins of habitable worlds. Excitement over JWST's discovery led to confusion. Some thought it found 7 Earth-like planets. In reality, JWST imaged one Saturn-mass planet, not 7 Earths. The mix-up likely came from the famous TRAPPIST-1 system, which has 7 rocky planets. TWA-7b is different, but its significance is huge. This is a technological breakthrough. JWST directly imaged a cool Saturn mass planet, something never done before. Previously, only massive glowing super-Jupiters could be seen this way. TWA-7b is smaller and fainter, a much tougher target. This success proves our technology is ready for the next challenge, imaging an Earth-like planet. TWA-7b is the dress rehearsal. It shows the method works and the telescope is up to the task. It's the first step toward finding another Earth. Direct imaging of TWA-7b is just one piece of JWST's puzzle. The telescope has already studied a diverse gallery of exoplanets. One standout is K218b, a sub-Neptune in its star's habitable zone, 120 light-years away. JWST detected methane and carbon dioxide in its atmosphere, key molecules for life. Even more intriguing, it found hints of dimethyl sulfide, a molecule produced by life on Earth. While not proof of life, it suggests K218b could be a Hycean world, a hot, ocean-covered planet with a hydrogen-rich atmosphere. JWST's atmospheric spectroscopy lets us search for biosignatures, gases that could indicate life. Each discovery, from TWA-7b to K218b, reveals a new facet of planetary diversity. We're learning how systems are built and what makes a world potentially habitable. JWST is bringing us closer to understanding the full range of worlds in our galaxy. We stand at a turning point in human history. The cosmos is opening up thanks to the James Webb Space Telescope. The direct imaging of TWA-7b marks a new era, turning theory into observable fact. Science advances with new tools, and JWST is our most powerful yet. The path to finding another Earth is built on steps like this. TWA-7b proves we can see smaller, cooler planets, bringing us closer to imaging an Earth twin. Each discovery refines our search for life. The universe is more complex and wonderful than we imagined. We're moving from asking if life exists elsewhere to searching for where and how to find it. JWST's data will fuel discoveries for years to come. We haven't found 7 Earths yet, but we're closer than ever. The question, "Are we alone?" remains. But now, we have the tools to seek the answer.